Hello and welcome to this video on sketching a graph using the gradient intercept method. So in a little video a while back, we looked at sketching using the X and Y intercepts, but this video will look at this method. So you might want to pause the video and attempt these questions, and if you're having trouble, then keep watching. Let's check it out. All right, just like I said before, we've previously sketched using the X and Y intercept method. This is called the gradient intercept method. So first thing to know is that we need to know that y equals mx plus c. All right, and what these variables mean. M is the gradient, which we know is rise over run, and c is the y-intercept. Okay, that's where the graph cuts the y-axis, cuts the vertical axis. All right. So it says sketch the following graph, y equals x take 3. All right, I've got a little process that I've made down here too. So maybe I'll just, let's have that to guide us. All right. Now, so to sketch the graph using the gradient intercept method, we are going to line it up with the general form of a linear equation. All right, we're going to line up this equation. So y equals mx plus c. Can you see that we can line up the values? So c here, will c be 3 or negative 3? It's actually going to be negative 3. Remember to take that sign out the front. So c is the y-intercept, which is negative 3. Okay. And m, what's m going to be? Well, x is x, and there's an invisible 1 in front of that x. So here, m is 1. The gradient is 1. Now, so we line it up, we align the equation, we mark in the y-intercept as the first point. All right, remember, this is our y-axis, this is our x-axis. The y-intercept is negative 3. So where it cuts the y-axis, so this is the origin. 0, negative 1, negative 2, negative 3. Nice. All right, now I'm going to actually mark that as an X point. That's our first point. Now we're going to look at that M value of the gradient, and we are going to equate it with the gradient formula. So M is 1, which is the same as rise over run. Okay, now any whole number can be written over itself as 1. Any whole number can be written divided by 1, all right? So the number 8 could be written as 8 over 1. Number 100 could be written as 100 over 1. So we can turn any integer into a fraction, is what I'm trying to say. And that is useful because now we can see that the rise is 1 and the run is 1, which leads us to our next step. Okay, if you're lost, just keep watching. We're going to do quite a few examples, all right? So we're going to make a right-angled triangle. All right, this is just an example, all right? So don't get too caught up with it. So we start at the y-intercept point, and we're going to make a right-angled triangle. Now, I'm going to choose to run first. I'm going to choose to run 1 unit first. So I'm going to run 1 unit across, just a dotted line, which gets us to there. And, whoops, I just drew an arrow. And then I'm going to rise positive 1 unit. So I'm going to rise up 1 unit. All right, and that is going to be my little right-angled triangle. Can you see that there's a right-angled triangle in there if I draw that? Okay, so let's do the line in pink. And then we just need 2 points to draw any linear equation. So that's our line. This is the graph of y equals x take 3. All right, we just keep trying. If it's not making sense just yet, all right, it will be all right. Now, following our method before, we're sketching this graph. So first step is line it up. Line it up with that general form of a linear equation. y equals mx plus c, and you can see c is 2, the y-intercept. M, the gradient, is 1 on 2. And we also know that the gradient formula is rise over run. And so I may as well just write that in now. All right, now come to your graph. We've got the x-axis, we've got the y-axis. Start by marking in your y-intercept. So y-intercept is the c value. So I'm going to mark in 2. And that, I'm going to put an X on there, a cross, because that's my first point. Okay, now we're going to do that thing where we equate the numerators of this gradient equation, right? So I now know that the rise is 1 and the run is 2. I'm going to use this to find my second point. All right, so I'm going to start at this gradient, at this intercept point, and I'm going to rise 1 unit. Let's do it in pink. Let's do it light pink, yeah. You can either choose to rise or run first, actually. I might run first. I'm going to run across 2 units from that y-intercept. See, I've run across 2 squares. I'll put a little dot. So, and then, so the run's done. And then I'm going to rise a positive 1 unit. So I'm going to rise up 1 unit and make my little right angle triangle. Remember, that's a little right angle triangle. So once I get to that point, I am going to then draw an X to mark my second point. Remember, I only need 2 points to draw a linear equation. And then that will go across the whole way. That really should have gone through the points. It's okay. All right. Anyway, that should work sort of like that. So that blue line is the graph of y equals half x plus 2. Let's keep going. Try and get this done. So again, another graph. This time I'm noticing something. It's got a negative gradient. All right, so maybe I'll like make a little note to myself just to check my answer at the end. I should expect it to go downhill from left to right because that's a negative gradient. But let's line it up and try and plot this. So again, writing directly underneath, y equals mx plus c. Now, that means that the m value is -3 and the y-intercept is 3. So you can write it in. I'm just going to write c is 3, y-int. M is -3. And remembering that you can write any whole number as over 1, as divided by 1, because that helps us equate our rise and run. Remember that thing? Numerator with numerator, denominator with denominator. All right, but anyway, now let's get to the graph. I have a point given already. Start with your y-intercept. So 0, 1, 2, 3 on that y-axis, and I'll mark it with an X as my first point halfway there. Now we are going to do that, making a right angle triangle using our gradient. All right, so I'm going to look at the denominator and I'm going to run across 1 unit, running along the ground. I'll put a dot there. And then I'm going to make the rest of my right angle triangle. So I've used the run, which is great. Now it's time to use my rise of -3. Now it's important, if the rise is negative, you're actually going to be falling. You're going to be dropping. So I'm going to be dropping 3 units from here. So dropping 3 squares. Let's go. 1 square, 2 square, 3 squares. And then I put my second point and I can just draw a line through that. Well, that wasn't very successful, but that's fine. You can just adjust it. Yeah, draw your graphs in pencil if you can. And this one's done. And remember, at the start, I pictured it was going to be a negative gradient, and it does have that slope. It's downhill from left to right. Where am I going here? All right, so I think you get the picture there. Let's check how many questions to go. All right, this will be last one we draw, and then let's check it out. All right, so line it up again. Y equals mx plus c. That means I'm lining up all the variables. X is x. M is the gradient, which is negative 5/3, which I know is rise over run. And I know that I'll need to start with my y-intercept, which is 2. So I'm given a point straight away. I'm given the y-intercept is 2. So I'll mark it on that y-axis. 1, 2. Mark it with an x. And then I look at my gradient. All right. And I look and it says rise of negative 5. That actually means I'll be falling. Remember, I'll be dropping. And then our run is 3. I'll start with the run. The run's the nice, easy one. I'm going to start at this y-intercept. I'm going to run across 3 units. That's 1 unit, 2 unit, 3 units. Okay, put a little dot. Let's form the rest of our right angle triangle. So I've used up the run. Now I'm looking at that numerator. Rising negative 5 actually means falling 5 units from that dot. So falling 5 units, 1 unit, 2 unit, 3 units, 4 units, 5 units. Put a dot. And then that's actually your second point. You've used your gradient to find that second point, which is great. And again, I haven't drawn it through the line, but you get the picture, right? It's got to go through those X's, okay? And you're forming that right angle triangle using your gradient, okay? Just going to check out, I've just said here, important, you must first ensure the equation is in the form y equals mx plus c before you can sketch, all right? In these past examples, everything's been with y as the subject already. Now, in these ones, which we're not going to draw, but we're just going to check that you can rearrange these equations to the form y equals mx plus c. So see how y isn't the subject? Let's get it to be the subject. All right. So there's a few ways that you can do it. All right. I circle the variable, helps me get my head around it. All right. Now, I know that I need to get y on its own. The furthest thing away from it is 6x. So I'm just going to choose to remove that first. All right, there's a video a while back on solving linear equations, which might help. But let's just use it using our knowledge of this. So I'm going to get rid of this 6x term first. All right, to undo that, it's a positive 6x. I'm going to take 6x. And what I do to one side, I must do to the other. Now let's simplify in the next line. I'll be left with, so the 6x's will cancel. 6x takes 6x is 0. We've got 2y. And then we're going to have 4 take 6x. All right, now I can circle my variable again. How can I get y on its own? What's happening to y? Now it is being multiplied by 2. There's a little invisible multiply sign there when you write things next to each other in algebra. So I'm going to divide by 2 on both sides because that's the opposite operation. Now those 2's will cancel and I'll be left with y equals. Now there's something you can do here, all right? You can separate it a little bit. So I could separate it as 4 on 2 and negative 6 on 2. And I'll show you that. So let's separate out that denominator. We've got 4 on 2, take 6x on 2. Okay, and I'm just trying to get it in this form, y equals mx plus c. So let's just keep simplifying a little bit more. 4 divided by 2 is 2, and 6 divided by 2 is 3. And then I don't know, I think it's nicer to write it with the x term first. Let's get it exactly like y equals mx plus c. So I'm going to choose to write that negative 3x plus 2. And then I've got it in that perfect form. And then you can see the gradient is negative 3 and c is 2. And let's quickly get this one done. All right, just in the same manner, we want to, if you're given this and you need to sketch it, we need to make y the subject. Okay, I circle y and I remove what's furthest away. What term is furthest away first? So I'm going to remove that x term. Now the opposite of negative 3x is positive 3x. So I'm going to plus 3x to this side, and what I do to one side I must do to the other. And then we just simplify in between each step. So negative 3x plus 3x cancels. We're left with 3y here. I'll just move this over a bit. And we got 6 plus 3x on this side. Now this is 3 times y. I need y on its own. I'm going to divide by 3. So those 3's cancel. And I'm going to divide by 3 on this side. The 3's cancel. I'm left with y. And remember how we can separate out that fraction so we can clearly see the x and y intercepts. I mean, the y-intercept and the gradient. So I can rewrite this with that separated. And then I can write it as 6 divided by 3 is 2. 3 divided by 3 is 1. Actually just sort of cancels and I'm left with x. And y equals mx plus c. Let's just rewrite it with the x term first. And then you can equate your terms, mx plus c. So what do you reckon the gradient is here for this equation? Remember, invisible ones. So the gradient is 1 there. And yeah, so maybe you want to take a little note of this slide. Yeah, hopefully that makes sense. And I will see you in the next video, which we're going to be determining the equation of a straight line this time. So we've been sketching the graph and sketching the gradient. We are now going to be looking at a graph and determining the equation from it. So I will see you then. See you later.